Q calculations practice problem number 1. So your first task is to carefully read through the word problem and then use that information to determine which Q formula or Q equation you should use. So how much energy is absorbed by 1,550 gram sample of water at 25.1 degrees Celsius? Q calculation practice problem number 1. So your task is to learn to read through these practice problems and figure out first which Q equation you should use to calculate the desired answer. So here is our first problem. How much energy is absorbed by 1,550 gram sample of water at 25.1 degrees Celsius that is heated until it reaches 85.3 degrees Celsius? The first thing that I notice is that there is a number that has a G tagged to it, which makes me recognize it represents a mass. So I'm going to mark it with an M. As I read through the word problem, I also noticed that there was another value that was tagged with a degree Celsius, and I recognize that is a temperature value. And at the very end of the word problem, there was another value tagged with a degree Celsius. A second temperature is present. So as I read through this word problem, I realize I have two temperatures. One must be an initial temperature, the other one a final temperature. So I see that my sample is at 25.1 degrees Celsius. So I'm going to recognize that as the initial or starting temperature, and it's being heated until, and that second temperature would be the final temperature. At the beginning of the word problem, I see the words how much. So that is an indicator that is my unknown. And what is attached to how much is the word energy. And energy is represented by the variable Q. So I must be solving for Q. And because I see I have two different temperatures, I am going to use the MC delta T equation. So Q is my unknown, equals, and therefore I must know my MC and delta T value. But I see that I'm not given the change, but I'm given two separate temperatures. Therefore, I'm going to rewrite the MC delta T like this. MC times TF minus TI, so I can substitute in a little bit more effectively. So I'll take the M value that I underlined up above and substitute that where M is in the equation. Then I have a TF in my equation, and I will substitute in my TF from the word problem. And once again, the initial temperature, I'll substitute in where the TI is. Now Q is my unknown, therefore I must know the C, which is the specific heat. I look back in the word problem, C value is not given, but I notice that my word problem is based on water. And I need to remember that values for water are listed on table B. So now I know where to get all of my information from. Now I can simply substitute it into the equation. So here we go. 1,550 replaces M in the equation. According to table B, 4.18 joules per gram degree Celsius replaces C. I put in the 85.3 degrees Celsius for TF, 55.1 degrees Celsius for TI, and then I'm going to pay attention to my units. And I notice that I have a gram up top, which crosses off a gram down below. I have a Celsius up top, or down below, sorry, and it crosses out the Celsiuses in the numerator. And then I am left with just a unit of J, which represents Q. Putting it into my calculator is pretty simple, and I end up with all of these digits. That's a lot of digits, a lot of significant digits, but I cannot keep them all. So when I look back, mass has 3, temperatures have 3, I need to only keep 3 from the calculated answer. So I'm going to keep the 195, but the digit to the right of the 5 makes it round up. So my sig figs are 196, and fill in with 3 zeros to maintain the value. So I have 196,000 joules.